We shall be starting our session soon, as we are waiting for some of the participants. Okay. Today's webinar is on CMMI High Maturity Essentials. Okay, a short description about CUNIX. CUNIX is a management consulting firm having experience of more than 30 years with 350 plus satisfied clients in over 19 countries. CUNIX is a CMMI Institute partner organization with 350 plus CMMI appraisals. In 2016, we were among the top 10 partners of CMMI Institute USA for new appraisals. I'm glad to introduce you to our presenter, Mr. Hitesh. Hitesh is the managing director at CUNIX. He is a CMMI Institute lead instructor and a high maturity lead appraiser for version 1.3 and 2.0. And I'm handing it over to Mr. Hitesh.
Good evening. Welcome to the webinar on interpreting CMMI high maturity practices. I'm Hitesh, and I think it's the right time to start, and we'll welcome some queries in the question box, which I shall take it up at the end. A lot of organizations wants to achieve this level 5, though all of them would like to achieve an excellence. Certification is just one part of excellence. However, every specific organization who would like to go for a level 5, they need to understand the essentials of high maturity. So high maturity means CMMI, implementing practices of CMMI level 4 and CMMI level 5. They are called maturity levels, and level 4 has got 2 process areas, OPP and QPM, and maturity level 5 has got another 2 process areas, causal analysis and resolution, and organization performance management. Every organization has got various problems. So where do we start from? Like improve employee turnover, improve support processes, rewards, recognition, accuracy, quality, benchmarking, ROI, recruitments, ethics, cycle time, customer satisfaction. There are so many areas that an organization would like to improve and excel. So normally, the first thing starts with what is the vision and the mission of the organization, where they want to be in X years, and mission means why we exist. That's a set of activities that you need to do to achieve the vision. They need to be careful that they keep the values of the organization intact while achieving the vision and mission. And on the basis of this, they can apply various methods to define a strategy, which is their game plan to achieve their vision. A strategy is basically a way to mobilize all the resources that are available at hand, internal, external, and global, to formulate ways to overcome the hurdles and achieve your vision. One of the methods to achieve this, to define the strategy and to roll it down, right down from the top management till the desk of each employee, is balance scorecard. It allows you to translate your vision and the goals, focus on them, and align all the activities with the goals. Balance scorecard has various pillars like financial, customer, internal, process improvement, and employee engagement. There's people management, and you need to achieve various strategies, various initiatives to achieve your goals. Another method is total quality management, and there are many more which I have not written over here. However, when you want to excel, the personal objectives of each employee needs to be aligned to the organization vision and mission, and we need to empower them. Some of the strategic outcomes can be satisfied shareholders, delighted customers, delighted employees, efficient and effective processes, and a motivated and prepared workforce. As I was talking about strategy, this is 3D linkage to strategy. So at a corporate level, we make a scorecard where you have financial objectives, measures, intermittent targets, and initiatives to achieve the target. And similarly, every organization, as it works for financial gains, that comes from the customers. And similarly, they are cascaded to customers, objectives, measures, targets, and initiatives. And then come internal processes where you have objectives, measures, targets, and initiatives. So quality improvement processes like ISO, CMMI, they come in internal process initiatives. That box that you see, the third row towards the right. And to achieve these improvements, learning and growth for employees is necessary. Now, this is at a corporate level. We need to further explore it down to division level and department level, or it can also be at a project level. They are aligned horizontally and vertically. And this entire picture and the framework is called a 3D linkage to strategy. It is strategy focused for the organization. To achieve any goal, you need to identify various objectives and goals. They need to be SMART, that is specific, measurable, achievable, or attainable, realistic, and time bound. What you see is a goal tree over here. If you want to achieve maximum profits, you have to reduce the cost, improve productivity, improve customer satisfaction. And if you want to improve productivity, you need to have on-time delivery, reduce rework, reduce defects. On the other branch, you have control attrition, employee delight, and competency management. The third branch, you have improve resource utilization. And I urge you to write down what one should do to improve resource utilization. Similarly, if you further want to write, you can also write, fill up the whole tree towards the second part that I have left for you. There is customer satisfaction. What we should do to achieve customer satisfaction. As you go down the tree, you'll find that there are various factors. They are called X factors, and they are independent variables, and they impact the outcome, that is the dependent variables. So any ideas that you'd like to write about improve resource utilization, you can put it in the box and we shall cover them up later. So once we have identified the goals, we go to a goal question matrix method where we have goals. If you see the table, you have goals, questions, name of the matrix, unit, formula, the source of data, the frequency of data collection. You can also add frequency of analysis, which is not shown here, criteria for bucketing them, and what type of statistics that you can apply also you can write, and the guidelines for achieving them. Once we decide these metrics, at a very basic level, that is when we are talking about level 2, measurement and analysis, you need to identify the problem and then do problem analysis. You have seen various methods over there. Problem identification can be done by check sheet, brainstorming, NGT technique, affinity diagram, or Pareto chart, cause effect diagrams, flow chart, run chart, pie chart, bar charts, etc. And for problem analysis, you have histograms, scatter diagrams, control chart, regression, process capability analysis, force field analysis. So using these tools, we identify the problem and analyze the problem at a high level. We'll go further and identify what needs to be done. So each problem, we have to identify from where it originates and where it can be controlled. and the life cycle of the project. And for that area of the process, that is called a sub process. So we need to realize what factor in that sub process is controllable and what factors are uncontrollable. And then we use these techniques to maximize the controllable factors to achieve excellence. And we also try to control the reduction in variation for the uncontrolled factors. So here what we see is a control chart. It's a statistical tool to understand process variation. And if you see, I'm sure most of you are aware about a control chart. This is also called process performance baseline, which is a key part of a process area called organization process performance. And we analyze these data from the past to understand whether the process is controlled and it is stable. If any of the points lies outside the control limit, we call it as an unstable process. There are various rules about identifying whether the process is controlled or not. One of the simplest rule and the basic rule is the variances that we find over here, they should be controlled within the upper and lower control limit. You see a point over there, which is an out of control point, and we should apply causal analysis activity on this to find out what are the cause that led to this particular instance. Once we find out the cause, we have to write procedures or take corrective actions like training or process improvement or fine-tuning the tool or changing some methods or defining some policies due to which it further does not happen in the next period. So the control chart also depends upon types of data, and we have nominal data, ordinal scale data, interval or ratio scale, and the various statistical techniques that we can apply are histogram, check sheet, Pareto chart, cause effect diagrams, defect concentration diagram, scatter diagram, and control charts. So some of these methods are based on discrete statistical variances, whereas some are not using discrete statistical variances. So what is a process performance baseline? A process performance baselines are derived by analyzing the collected measures to establish a distribution, the range of results that characterize the expected performance for selected processes when used on any individual project in the organization. So control chart can be a type of baseline, or box plot diagrams can also be a type of baseline. It basically gives the character or a pattern of the data and the performance behavior of that particular sub-process. If you see further in this diagram, we have upper control limit and lower control limit, and the width of the control limits is divided into 6 zones, 3 above central line and 3 below the central line. They are called zone A, B, and C respectively. And the entire control limit is called 6 sigma, and each one of the bands represent a performance of 1 sigma. So there are multiple tests which are used for identifying whether the process is stable or unstable. The first test says that the point is outside the control limit, upper or lower control limit, and that shows that this is an uncontrolled chart. The second test talks of 2 out of 3 points are beyond a particular zone B. So there is a high variation. And the third test talks of 4 out of 5 points are, as you see, they are there in control B, in a zone B. Test 4 talks about 8 successive points on same side of the center line. That means 8 is like tossing a coin 256 times, and if that is 2 raised to 8, and if all the 256 times you get heads or all the 256 times you get tails, that means there is something wrong and it's not a natural process. So these are some of the tests that identify whether the process is stable or unstable. Most of the time the organizations always use a test 1, which may not be sufficient, and that may not be called a stable process. You have one more example of XMR chart for daily customer service effort. So this chart, if you look at the top, all the points are within the control limits. This may not be an ideal case because normally when you draw a control chart, you normally get 1 or 2 points outside the control limit. We have, as I said before, we have to identify those signals, identify the special cause of their variation, why the variation is so high. Once you identify the special cause, you have to remove the cause by corrective and preventive measures so that it does not happen again. And the next cycle, these causes are removed, and you can hope that other causes still do not cause any special cause of variation, and you can get the points which are within control limits. It might take 2 or 3 cycles of data analysis till you get a stable control chart. So process normally is unstable, and it takes some time and a few data analysis cycle to bring it into control. And this is the outcome where you can say process is stable. Any data points according to those 4 rules do not follow the rules of the control chart, then it is called an unstable process. This is another example of box plot or box and whisker plot, where you can understand the extreme lines are the range, and you have a mid central lines that you see between 70 and 80. However, the diagram is not as descriptive as a control chart, but you'll at least get the range and the central line. It also shows the skewed nature of the data points around the central line. So for high maturity practices, we use a DEMIAC framework. As you are seeing, it basically defines the problem. Then it goes to measuring the problem, where you actually define the sub-process which is creating a problem, and you measure an attribute of the sub-process which is related to the cause. In analyze, we determine the root cause of issues or defects. In the improve phase, you are going to look at what are the improvements that we are treating the sub-process so that these incidents don't happen again. In the last phase is control, that is to bring the process under statistical control. So, what are the situations that lead to non-controllable processes? Because the science is about getting the processes under control, thus the performance comes under control, thus the performance becomes predictable, and you can predict the probability at which you can achieve your goals. Some of the processes are lack of process compliance, undistinguished influences of multiple underlying sub-processes on data. So there may be multiple sub-processes which are getting cascaded, and their effect results into an uncontrolled process. So if you see any outlier, that means it's a culmination of many sub-causes, or it is just a culmination of one particular cause. Third is ordering of or timing of activities within the sub-process changes. Uncontrolled inputs to the processes like schedule pressure or environment change. Environmental changes during the sub-process execution with respect to change in people, skills, resources, support management, inappropriate sampling or grouping of data, data organization and issue analysis issues due to random sampling, irrational or non-homogeneous subgrouping, and using averages of out of control processes. Sometimes there are new processes that are developed, or substantial tailoring of processes when past data may not be useful. You have new domain, new technology, new teams, due to which there are high variations in the process performance. And when the control limits are too wide, right, some signals are masked, so that those are the false signals then, or they are hidden signals. Uncertainty and vulnerability and undefined sources of variation or erroneous data. So these are some of the reasons due to which we have uncontrolled processes. When you make a control chart, you have to check for root causes, and you'll find some of these can be present. This is a brief diagram of process measurement framework. Initially, you start with clarify the business goals, identify and prioritize issues. You have so many of business goals, but you have to look at which are the teething problems today. Select and define the measures, focusing on which are the problems and issues that are prioritized to control. Collect and verify the data. Analyze the process behavior using process performance baselines, and we discussed about it in control charts and box plots. Check if the process is stable. If not, remove the assignable causes, and you may have to collect some new measures. And if you are successful, go to new issues and find out new problems to solve. It's a continuous cycle. And the problems are solved, then you go for a new goal and start doing it again. If the process is stable, then you have to check if the process is capable. So for capable processes, you need to look at the specification limits, that is the management control limits defined by the management, which qualifies that the process upper and lower control limits, whether they lie within the specification limits. And this leads to process of continuous improvement. The stable process characteristics are: the process is stable when all the data points are under the control limits and there is no outlier or there are no signals. Also, the stability of the process depends on whether the process has sufficient support, faithful execution of the process, and a good fit of the process into its operating context. Basically, stability answers the question: if the process is stable, can we correctly predict the behavior of the process? This is required. To predict the behavior, the stability of the process is necessary. And the capability says, is the process capable of achieving its organizational goals? And that comes from specification limits. How do we identify the critical sub-processes and processes? So we start with the business objectives and derive sub-objectives like quality and process performance objectives. The meaning of quality and process performance objective is: quality processes focuses on the product, and process performance objectives focuses on the support processes, which are like effort, schedule, cost, productivity, etc. The definition of quality objectives would be defects or design sustainment, technical performance, and so on. So once we have designed the process performance baselines, we look at process performance models, where you have it comes in the form of an equation. On the left hand side, you have a variable which is about what you want to predict. It is in the form of y equal to fx. And on the right hand side, you have the independent variable. Left is called a dependent variable, which is dependent on the independent variable towards the right. So you can predict the development effort or defect fixing effort. Normally the y, that is a dependent variable, is the one process that is towards the end of the life cycle, and x is a measure of a process which is before the y. So it's like you use the x of an early process so that you can predict the performance of the future process. We'll talk about barriers to building the process performance models, lack of realistic goals or whys, insufficient management sponsorship and involvement, lack of identification of correct X and Y. How do we identify relation between X and Y and say whether they are correct? Any pair of X and Y, if they are increasing, that does not mean that they are related, or if they are decreasing, that doesn't mean they are related. There are three basic rules for identifying a correct correlation or a process performance model. The first rule is mathematical relation. Second rule talks about the consistency, so that as X varies, the Y varies in the same way. This is done through sensitivity analysis and hypothesis testing method. The third is cause-effect relationship. That means that any change in X will bring about a change in Y. That is a cause-effect relationship. If you are looking at the price of gold compared to the price of dollar, well, it looks like there are a lot of charts that we see in newspapers that between X and Y, but you need to actually see whether is there any relationship or a cause-effect relationship between the price of gold and price of a dollar. So these three tests will tell you whether this particular correlation or process performance model is real. Another barrier is insufficient competency to identify the predictor X and Y, and insufficient training or practice for modeling techniques. The requirements for building process performance model is identify related X and Y, identify the outcome measure and the dependent variable X and its data type, statistical evidence that X factors are significant to Y, statistical evidence of the strength of the model, that is the adjusted R square value, which you'll see in the equation when you use Minitab or SPSS tools. The actual prediction equation for the outcome, we just saw an equation. The performance baselines of the X factors, because when you use X and Y in a process performance model, it is a prerequisite that X is stable. That is shown through process performance baseline. And the confidence in the prediction intervals of the predicted outcome. So using these requirements, it's necessary that you study first the X and the Y variables before we build a process performance model. Same way, when you use a process performance model at organization level, you can also use a process performance baseline and process performance model at quantitative project management. That is, means each project, and make the PPB stable in each project so that whatever you predict using the process performance model, that can be useful in prediction of the sub-processes of the projects, and you can predict them and control them. When we go to level 5, you have a process area called causal analysis, and you have to study the past performance in the root causes, categorize the root causes, and remove these causes for future successes. So some of the CAR where you can apply CAR can be defects, risks, issues, incidents, or problems. It consists of sub-processes like defect reporting, causal analysis, action planning, and prevention feedback. The main questions that you have is, how could I have prevented this defect? What are the ways by which I would have taken actions to remove the causes so that these defects don't occur in future? And on the way, you will find some probing questions also. Why I'm doing CAR? So it should be related to business objectives. What are the business goals you'd like to hit this year? How are you communicating business goals throughout the company so that they are aware of the hindrances and the causes that has to be removed? How are you tracking progress for these goals? What work must be done to harmonize all systems and processes? What must I do to achieve detailed thinking on a continuous basis? How can I create rapid solutions for prevention while thinking at a slower rate? And these intriguing questions will always come when you are doing causal analysis, because you have to go in the past and understand the nature and the character of your processes. This includes problems of the past, the habits of people, the culture of the organization, whether there is a process focus, some unstable processes, direction of business, senior management consistency, fidelity of implementation, and such factors. So if I take a small example, you have, as you see on the top left, you have various types of defects in the first column. You have the percentage of defects, and then you have cumulative defects. And you have a Pareto chart, 80-20 chart, which shows that you can combat with the first 2 or 3 categories of defects. The first 3 categories of defects in this case amounts to 69% of the number of defects, and that's where you pick up the top 3 causes, and if you resolve them, you'll get benefits on the 69% of these defects. When you identify each of these 3 categories that we have chosen and do a fishbone diagram like specification defects, and for the fishbone diagram, you have, I'm sure you are aware of this, and you identify the key causes that you see in dotted lines. How to identify the key causes? So here you use hypothesis testing or ANOVA and see if removing these causes will affect the category in which these defects are resident. So hypothesis testing and ANOVA should help you to identify these areas. Here you identify that, well, training is one of the causes, and another cause is, customer gave wrong information. So these are the things that you need to identify, which are the major contributors to the specification defects apart from other causes. Now, once you pick up these defects and plot a control chart, you find that if you see the upper part, you have a stable control chart, right? But the limits are very wide. If you see from 0 at a LCL to it goes till 44.9, very wide range. This may not be a real acceptable case. Your central line, that is average variation, is 22 number of defects. So if you go to a customer with this, the customer may say, I may not be able to live with this, performance, that on an average, if you are going to give me 22 defects per unit, it may not work. So customer may say that I would like to work with you not more than 10 defects. And that is called specification limits. And your chart does not, follow that particular limits. So you have to go for a causal analysis. This is an example where you have a stable chart, but it is not capable. It is stable within wider limits, but it's not capable, it's not acceptable to the customer. So the next chart talks about how all these defects are categorized into 8 different subcategories. This is called segmentation or stratification. And you draw a control chart on each of these categories. So if you see the categories where each one of them have got a control chart, that is functions, timing, checking, build and packaging, interface, algorithm, assignments, and documentation. So it's a divide and rule technique. So you're finding out in each category which are the outliers. So most of the categories, if you see, except the timings, they have an outlier. So if you make 8 such categories and 7 are unstable, you can identify 7 defects at a time 7 causes at a time, apply corrective action for each of these 7 causes so that they don't repeat in the next quarter. And in the next quarter, you may have a better chart. So after application, this may take some time because you have to take corrective actions. It may include improving policies, procedures, tools, adjustments, training, skills, capabilities, etc. So now, after you have removed these things in the next quarter, you have another control chart where your upper control limit has reduced from 44 to 24, and the central line has improved from 22 to 15. But if you still look at the specification limits of the customer, he wants average number of defects not more than 10. So we have improved the capability of this particular process by removing several causes of defects and thus the defects, but it is still not a capable process, though it is stable. It doesn't satisfy the customer limit. Well, you have to do it again, the previous process with the new set of defects. Remove, identify some more outliers and signals, and finally again see what you get. Probably you may get some better control line till you reach the limit of 10 or lesser. That is when your process is said to be capable, when the defects, your mean gets below 10. This is a continuous improvement, and it, as I said before, it may not finish in 1 or 2 cycles. It may take some more cycles, and that's where the actual improvement factory is manifested. So when you are doing, again I will repeat, there are queries on process performance models and prediction. So when you do causal analysis and when you are in the improvement cycle, you can check with process performance model, as your number of defects are reducing, your Y, like total effort or total cost, will also reduce. Some of the predictable outcomes in a process performance model can be escape defects by phase, schedule variation, task duration, estimated effort, earned value metrics, or customer satisfaction, cost variance, productivity or rework, or cost of poor quality. These are the things that you'd like to control as Y, and for X you have to identify what can be the causes. That's where you see controllable factors X to predict Y. So there are some people X factors like training, resource availability, degree of disturbance, degree of multitasking, team diversity with respect to staff or attitude and culture, and leadership issues. There can be factors, X factors, due to environment, nature of work, facilities, management behavior, external interferences, different types of distractions, ergonomic facilities, logistics, etc. Weather. So if you are in extreme weather, then there are disturbances which would impact the performance. There can be technology factors also, where you are looking at degree of modern tools, complexity of technology, availability of technology, skills available, platforms and programming languages and operating systems. So these are the factors that would affect a particular Y. Then there are process X factors, about how good are the process compliance, resolution time of technical inquiries and process support, and process compliance, product quality, review measures. There are customer, supply, and other stakeholder factors also written on towards the right. Staff volatility, process maturity index, geography, dispersion of the team or the suppliers. So these are the factors that needs to be controlled in order to get a better Y or the goal achievement. So we already discussed some of these steps for building a process performance model, right? And what are the skills needed to develop the process performance model? You need to understand, apart from statistics, you need to understand the nature of the project and business acumen to understand what's beneficial in terms of getting a goal achieved. product and process expertise, understanding of measurement and analysis techniques, statistical techniques, understanding QPM, CAR or OPM or innovations, statistical skills, build teams to understand the process and the context in which the PPMs will be used. So you need to understand the CMMI concept, you need to understand the statistical techniques and tools and interpretations, and you also need to understand the business context. So in brief, what we see is here is the OPP practices, establish quality and process performance objectives, and how it affects organization performance management. So the arrows are showing the impacts and the use of artifacts in OPP, like SP 1.4, established process performance baseline, is used for checking the innovations and goals and analysis of process performance data. Here you also have various impacts of activities between the process performance model and the process performance baselines. So I think we have already been talking for about 43 minutes and it's almost time up. We can talk more and we'll design, in case if you send some questions, we'll take it up when we select the topic in the next webinar. Let us know if 100 messages. So there are some questions like how much time is required for a level 3 company to get certified to level 5? So, well, I can tell you the minimum time recommended by CMMI is about 18 months. However, it depends upon the rigor with which you collect the data and analyze and control the improvements, because it is not about just making documents. You need to have enough amount of data for analysis. You need to first stabilize the data, make the process stable, then apply to projects, use for QPM, quantitative project management. Once the projects are stable, then you are confident of a level 4, and then you have to go for level 5 where you should have innovations. What new things you have done in the organization so that the your business goals are achieved using process performance models and process performance baselines. What are the causal analysis activities that you have taken to eliminate the causes that are hindering your success? These things do take time and is a function of how you study the data and how you analyze the data. Couple of time cycles are required, and as a normal pace of the organization, it should take about 1.5 to 2 years minimum for reaching a level 5. Management culture, nature of projects also play a very important role, and that should be considered. Thus, we cannot give a specific time, but the range would be 1.5 to 2 years minimum. So there is one more question. What should be the team size? The question is what's the minimum team size to go for level 3? The question looks to be incomplete. Minimum size of the company or minimum size of a project or minimum size of quality team, it is not very clear. But I have appraised companies which are like also 17 to 18 people in the company, and if at all the organization is capable to demonstrate this 18 process areas of level 3 for development, it depends upon the capability, not on the size. But my experience goes to like up to 15 people. Lesser than that would be difficult because each person then would be doing more than one process areas, which is possible. But then as the team size is smaller, the load per project and per person would be high. I hope this answers your question. If at all your team size is talking about quality team, I would suggest at least one full-time person should be there in any organization beyond like 35 people. Otherwise, the load of QA work can be shared by part-time representatives. And we have one more question which talks, is it a must to demonstrate improvement at the end of each PPB? Yes, you should demonstrate some improvement at the end of each PPB. However, the first process performance baseline is just a picture in front of you, and you analyze it, do causal analysis, and that should be reflected in the second process performance baselines. But if you're doing the job well, then you will see some improvement at the end of each process performance baselines. We don't have any further questions now. Thank you for all the questions. And okay, there is one more. Can a software company go for a CMMI level 3? Simple answer is yes, a software product company can go for CMMI level 3. However, the way you implement product and process will be different. Chat. There is one question from Thompson. How much time is required for level 3 to get certified to level 5? I think we have already covered that. And one question talks about, I need some knowledge about process performance model. Well, we can help you. I'll send you my email, and it was there in the presentation. Can we nominate same projects in level 5, which was a part of level 3, or we require new? Yes. So if your projects are still running, they are long projects, let's say 2 years and 3 years, and you can use the same type of projects. But however, the selection of projects which are sampled for an appraisal will definitely depend upon CMMI guidelines and the lead appraiser. Because if you have 20 projects in level 3 and you have selected 3 projects as sample, there is no guarantee, or it is really not required that you should use the same 3 for level 5. The lead appraiser may select different projects. And in version 2.0, even the lead appraisers don't have this right to select the projects. We have to send it to CMMI, and they are going to select the project. So the answer probably will be a no over here. You may get some of these projects selected by CMMI in version 2.0. Another question is, can you elaborate the PCB and PPB and how you can link it to balance scorecard and CMMI? I can do that on a separate call. I think we are running short of time here. It's a long discussion, and we are ready to help or guide you. Please send me a mail and I'll do the needful. Does CMMI V2 also have the same 5 levels of maturity level, with each having a set of process to implement, or it's more of a capability? It is. In V2, you have certain changes in the process areas. They are called practice areas in version 2.0. And some of the practice areas are merged, like requirements management and requirements development are merged. Some practice areas are new. So I would really encourage you to look at V2.0 and look at the changes. Some process areas have expanded the scope, like risk management is risk and opportunity management, verification, validation is together. So I would suggest you look at a V2.0 model. It's quite different. The structure of each practice area is different than what you used to see in V2 1.3. Next question is, when we have very negative lessons learned from previous project is, I think the question is not readable. I'm sorry, we can't decipher the coded language in which the question is written. Skills required to reach level 5, that is from Smita Ranginwar. I already discussed some of the skills. You should have a business acumen. First of all, you should involve not only the technical and quality people, you should involve some people from senior management, and sometimes the peer review of these artifacts by finance people also would be necessary, so that they can identify the ROI, return on investment, of your improvements. Otherwise the improvements will be so small or insignificant or remain on paper, but they not be significant enough to convince that it's a world-class company or you have really achieved good improvements. Now I'm working for level 5. Can we go with 1.3 or 2.0? You can select 1.3 or 2.0. 1.3 appraisals are valid till September 2020, but you can go for 2.0 much before that also. Is process composition required as requirements to CMMI level 5? Yes, process composition will be required to optimize your processes and suit the goals and the needs of statistics, as well as how to optimize the performance to get level 5. We have a few more. When we have projects of varied nature and new each time, then lessons learned from previous project is a challenge. So lessons learned from previous project, if they are about people, habits, tools, processes, it may not be a challenge. You can always learn and they are common. However, technical issues may vary from project to project, but the type of risks and the issues about people, projects, issues with your team, management skills, some of these lessons learned can be common and you can reuse them. Well, if it is a challenge, we should take the challenge and start collecting lessons learned from the current project phases, so that lessons learned in early phases can be used at a later stage in the same project. The next question is, if an organization was level 5 but not ready to do much on the ground level, then can it still be doable? Well, I'm afraid they want it, but they don't have the capability. So in that case, they have to look at the management, why they want to do it. And to make it doable, they have to invest in people or processes, effort and hard work to implement these processes. Because if you have a desire but not the capability, then probably you cannot do it. So these were the questions. Thank you very much for the questions, and it was very enlightening to have this webinar with you. Thank you very much. You can mail your questions to hitesh@cunixinfotech.com. Please take care of yourself, and thank you very much.